Hello, my name is Rabiha Shaheen and I am a computer. I did my bachelor's in computer science. So my core subjects are all related to the field of computer science, data science, data, or machine learning, artificial software development, and many more. So today, I'm just gonna give you an overview of big data. There are some basic steps that happen in my class. There are some codes which are for teachers and introduction, then followed by the students. And the next thing, which is that is some recommending study sources, which I'll be providing as well. Then there is performance evaluation and contact based on what the student is learning and what the teacher is teaching. Overall, in depth, like reviewing each other. Then there is course introduction and its objectives, big data analytics, view of that, major course content, and data analytics life. Then there are some tools and technologies which I'll be explaining about regarding big data, which will be used and which will be taught in this. So there are some important books which are Mining of Massive Data Sets and the third edition of this. Most of the data are the context which I'm going to refer to in this topic is based on that big book. Then there is Data Science and Big Data Analytics, EMC Education Services. And then there are some notes, some sample problems, some lecture slides, which I'll be providing. Some of the major course contents includes an introduction about big data analytics, the life cycle of data analytics, and the overall like theorems and algorithms and tools which will be implemented in big data. Then there are some advanced tools and technologies which I'll be teaching as well based on SQL or database using R language, using Python, Hadoop. So first of all, the first thing is an introduction to big data. An introduction to big data, what actually is big data analytics? As we can clearly see, this definition defines what big data analytics means for us. The big data analytics is the process of collecting, examining, and analyzing large amount of data. As in, can be any type of data which we'll be using to produce a model, and then we will be using that model for future work. These works can be based on medical sciences, or these can be based on sports or academic ranking, anything that right now the person is willing to make improvement. So this is what we do. We collect past data and we derive models from them, which helps us in future. So this is overall what big data helps us. Then in the second definition, which is by McKinsey Global Report, which was found in 2018, it tells us something more about big data analytics itself. It says that big data is just not about collecting, examining, or analyzing some large amount of data. It's also about the scale and the scale, distribution, and diversity of that data being used in multiple resources. It can be in which field it is used, what is the architecture which is being built based on some specified data. And also, these are some of the systems where big data is mostly used. That includes healthcare, education, so insurance, artificial intelligence, retail, and manufacturing. So this is all we are going to work on. We are going to learn how we collect data. We are going to learn how to set up a model based on data, how we um, like filter the data, how we drop the null value or use the noise, like moving the zero values from the data. So this is overall what we are going to learn in this course. So big data characteristics are built upon five V's. There are basically three important V's, which are volume, variety, and value. Yeah. So these are the most important V's, but there are two more important characteristics which we do consider. First of all, the volume of data set. Like how the data, like what is the volume, how much data we have, how much large data we have on which. model of. Then the variety of data. Is it structured or is it semi-structured? When it comes to structured or semi-structured, it means what is structured data? Structured data is this type of data where the data is quite organized in the form of rows and columns, or there can be proper flow charts. Like something by looking at what we will be able to understand what is the purpose of that specified file. When we come to semi-structured data, it can be a text file similar to that of a Word file with some tables or tabular format being inherited into it. And it will also be quite clarified based on unstructured data, which is just going to be some plain text or some type of code. So that is how we judge the variety of some data, and how we need to be very careful based on what type of data we are using for our mod. Then comes the third characteristics, which is the velocity. Velocity, as in at which speed this data is being currently used at multiple stages. Like where is this data being used? What is the significance of this data? How is data is being generated? This is what overall, like at what speed this data is being generated. This is what overall velocity covers. Then there is veracity. Veracity is like what are the sources from where we are getting the data. Noise means, like, let's say we have some few columns and we have some rows as well. There is some data here, and then there is this row which is zero. Then there is this row which is zero. This one is already empty. And this is noise. That some null values or some empty rows or some inconsistent values which are being like implemented into a data will be removed. So the less noise the data have, the better the data is, because we don't have to work more on filtering. The last thing is value. Value is what type of trends are being collected, what type of correlations are being made based on the data set that we are gathering, and what type of information that data contains. Here are the five V's which are being explained when we come to volume. Volume, as I have explained, like how much, how large the data is. Okay. Is it in terabytes? Is it in form of records or archives? Is this based on transactions? Is it tables or files? Okay. So I've also explained structured and semi-structured, quasi-structured, and unstructured data here. So structured data, there is an example of why do we firstly need structured data. When it comes to variety, there are four types: structured, semi-structured, multi-factor, probabilistic. So structured is an RDMS system, like a management system, which will be quite organized, where there will be different machine types based off like RDMS system of call center. That system will contain some structured data of machine types, stamps. Then there will also be some unstructured data of chat history, transcript of calls. Okay. Then when it comes to semi-structured is some textual data with some pattern or some tabular format. Third one is quasi-structure. In this form, we use tools to convert unstructured data into structured or semi-structured format. This whole problem is known as quasi-structure. Last one is unstructured, where there is, as I've explained, just a simple text file or just video or an image, where there is no flow which can be cached by looking at the data. Data can be in form of tables, the data can be in form of images, it can also be in form of videos, it can also be in form of code. These are some of the examples for structured, semi-structured. Then the third thing is variety. Veracity is like what is the availability of the data, what is the accountability of the data, is this data trustworthy, do we have the authenticity of the data, from where do we get this data, and what overall reputation of is in the market. Then there is velocity. Velocity as in speed. So is this data being gathered in batches, or it is just based on real time or then how many processes are being implied, and for streams. Now, for streams, it is live stream. Is this data being collected by streaming? Then, when we come the last V, which is value, the value of data is statistical. Then, will it implement more statistical value? Will it implement more events as compared